Okay, so we're going to start looking at the sheep brain. And what I have here are two different brains, just kind of to give an idea of what's going on. This is covered with the dense fibrous tissue known as that dura mater. So that's what this real thick stuff is on here. And what's nice about these brains, the way they come, is that it allows you to see some things that you normally would not. So here, this is some bone. This is part of like the ethmoid bone. Remember, the ethmoid bone has the crista galli. The crista galli is where our dura mater is actually going to attach to that ethmoid bone. And then it also has the cribriform plate where the olfactory bulb has all of the little olfactory neurons that run down into olfactory nerves that run down into the nasal cavity. So as we go through this, we're going to cut this bone off here and expose those olfactory bulbs. So we can see this dense line here. This is known as the false cerebri, and this is that thick dura mater that creates our sinuses. Posteriorly, we have our cerebellum, and it too is covered by that dura mater. And then this is the beginning of our spinal cord down here as well. If we look again over here, I want to point out a couple things real quick. This here is our optic chiasm, and we're going to see that the optic nerve is running up this way. We're going to pull all of this off of here. This is some fat and muscle here. Here's the optic nerve over here, and the two nerves come down and merge at this optic chiasm. And so this optic nerve is going to come down and form the optic tract over here. This optic nerve comes down and then will form the optic tract going back this way. The other thing that we can see here is this structure here. This is our pituitary gland. Now our pituitary gland, you can see, is part covered with this dura mater. If I kind of pull that down there, this is that pituitary gland here. When we cut this dura mater off, we no longer will see that gland. And then this one here is beautiful because it has this very thick trigeminal nerve. When I take the dura mater off, I will try and maintain that trigeminal nerve. If we look on this one here, you can see him also a little bit on the side. This one here is already cut, so it's not going to be able to be maintained. This one I might be able to maintain a little bit. This also is already, the optic nerve here is broken off on this fatty tissue. So we're going to have a much smaller optic nerve on this brain itself as well. Okay, so I'm going to start, I think, with this one here just to give you an idea of how this gets dissected. So carefully, I'm going to kind of create a little incision here in this dura mater. And as I do this, let me flip that around this way. What I'm going to do is, by lifting up, I'm going to cut all the way down this, the side of the false cerebri, so that we can expose some of that brain tissue underneath. And I'm also going to kind of just cut up this way here, a little anteriorly. Now, again, remember that optic bulb or the olfactory bulb is underneath this ethmoid bone here. So I want to be very careful when I try to take that off and help maintain. Let me cut this a little bit. Kind of pull that up off of that optic bulb there. And there it is. Okay. And the same thing on this side. And there's the other one. So you can see I kind of maintained that optic bulb right there. Now, as I come back posteriorly, this is going to be a little more challenging because this false cerebelli is much thicker and much denser. So I'm going to begin with the dura mater down on this end of the brain stem and kind of cut up here. Okay. And then kind of start to pull that back a little bit as well. And then very intensely, I am going to cut down this membrane off. All right, so you can see what we have here is our cerebrum here, the cerebellum here, and I'm going to lift this dura mater up out of between those two. Okay, so you can see that kind of is coming all the way off like that. Now, again, trying to maintain these trigeminal nerves is going to be a little challenging, but what I do want to maintain is what we call the oculomotor nerve. Now, that is going to be inside here. If you see this little nerve, if I can get it to zoom in, there is a little nerve kind of attached here. Nope, all you're seeing is my hand. This little nerve right there. I'm going to detach that from the dura mater, just like that. And I will try and do it on this side on the video as well, if I can. Where are we? There. And I got it there. So you can see it's still kind of holding on right there. That is our oculomotor nerve. And then all of these here, these are still other cranial nerves. I'm just going to detach them just to make it a little easier to get this dura mater off. And that large, thick trigeminal nerve is probably going to get lost there as well. Like it did on the other side, but that's okay. Let's just kind of cut it there. Whoops. Okay, now the other thing we have here is that pituitary gland. I need to be careful in trying to get that off, but it is there. My last concern now is my optic chiasm. So in trying to maintain this optic chiasm and as much of my optic nerve, I am going to cut off all of this here, this membrane in this direction, and all the way around this optic chiasm here. And in turn, and just come up here where that nerve is still attached and cut it off like that. So what you can see now is that there's a little bit of that optic nerve, but I've left that dura mater there around that optic chiasm and that optic nerve just so it's easier to work with without the risk of breaking it off. Okay, so that's what we've got going there. So now this is actually a beautiful looking brain. It's got perfect little color to it as we look at it. So I have here the dura mater that is completely cut off. On that dura mater is the pituitary gland still there, okay? But let's look at the superficial and features of this brain. So this part here is our cerebrum. We have the cerebellum here. This is the beginning of the spinal cord and part of the brain stem down here. If we look on the inferior side, again, we have our olfactory bulbs. You can see them here. The olfactory bulbs have the olfactory nerves that go down into that nasal cavity. So this is cranial nerve number 1, the olfactory nerve. It is purely sensory. And then it leads down into the optic or olfactory tract, carrying that information back to the temporal lobe there, okay? And then we have cranial nerve number 2, and this is the optic nerve. Again, the optic nerve comes down and crosses over here at what's known as the optic chiasm. And then you can see, if I remove a little bit more of this dura mater here, what you can see is this region here. This is the optic tract as it's going down, okay? So we have olfactory bulb feeding into our olfactory tract. We have the optic nerve coming down into the optic chiasm, going down into the optic tract there, okay? That's cranial nerve number 2. If I come just a little further down on the midbrain, I have here my 2 little pieces of the ocular motor nerve. Those are cranial nerve number 3. And I did maintain a little bit of this trigeminal nerve over here, which is cranial nerve number 5. So we have those all on there. Now, just to keep kind of pointing out a few more features on this before we go any further. So if this is my optic chiasm, what I have underneath my optic chiasm, if you see this hole here, this hole is the where the infundibulum, the stem, the neural stem that comes from the hypothalamus, attaches here. So this represents the infundibulum, and the infundibulum attaches to the pituitary gland that we have over here on the dura mater still. So you can see sometimes parts of the infundibulum remain. This time it just, all you see is that nice little hole there, okay? Inferior to the infundibulum, so the infundibulum is part of the hypothalamus. This here, these 2 little round bulbs here, these are the mammillary bodies. These are also part of the hypothalamus. These are nuclei that suspend outside of the hypothalamus, and so that's why you have it, you know, you're able to see them on this external surface here. And then again, these are the ocular motor nerves. Now, these are actually attached to the midbrain. The midbrain is part of the brain stem. So this is cranial nerve number 3, and that's part of our midbrain here. And then we have our pons. This is also part of the brain stem here. It leads down into the medulla oblongata. I guess this whole area here would be close to the pons. And then the medulla oblongata, the medulla leading into the spinal cord, okay? What I'd like to do is actually just kind of go to that superior view one more time and point out a couple things. We have the longitudinal fissure that's running here. We're going to have the lateral fissure that runs over here. If you can see right here, so if this is my longitudinal fissure running here, this here is going to be that central sulcus, okay, the central sulcus that kind of goes all the way down. Now, separating the cerebellum, the cerebrum from the cerebellum, if I slowly pull this down, what I want you to see is that this is part of the midbrain here, known as the superior colliculi. So I always call those the little bums. That's the superior colliculi. And then below it, you can actually see the smaller 2 bumps there. Those are the inferior colliculi. So if I pull that cerebellum down just a little more, you have the superior colliculi here. You have the inferior colliculi down here. Now, that's part of the midbrain, which is part of the brainstem. If I lift that up just a little bit, and hopefully the lighting allows you to see it. If you see this little tiny beanie structure inside here, that is our pineal gland. Now the pineal gland is part of the epithalamus, so that's part of the diencephalon. And the pineal gland is involved in secreting melatonin, which helps with our sleep-wake cycle. Okay, so that's what we show inside there, is that pineal gland. So you can see the superior colliculi, the inferior colliculi, and that pineal gland. Pineal gland is part of the epithalamus. The colliculi are part of the midbrain, and then our cerebellum. Okay, so those are the external features of the brain. When we take our sagittal section, we will look at those sagittal features as well.